There we go. Our first problem, the directions say simplify. So numbers 1 and 2, our job is to simplify. I always recommend factoring first. Factor first. These are two trinomials. Okay, the numerator and the denominator are both trinomials. We know that because there's 3 terms and we have things that are added and subtracted together. Okay, and so we are going to try to factor this into 2 binomials, and we'll see what happens. So the very first one, I can take an x out because I have an x in all 3 terms. I have an x in all 3 terms. So then I'm left with x squared plus 10x plus 21. Okay, and hopefully you're thinking, okay, that can be factored further. But we've taken out that greatest common factor first. Now I'm just going ahead and rewriting the bottom. The bottom can be factored, but it doesn't have a GCF for us to take out. So I'm back on the top. I have x squared plus 10x plus 21. My product is 21. And my sum is 10. So my 2 numbers are 7 and 3. 3 times 7 equals 21. 3 plus 7 equals 10. So I've got x plus 7 and x plus 3. That's in my numerator. Now my denominator, I have a product of 56 and a sum of 15. My numbers here are 7 and 8. And a way to remember that 7 times 8 is 56 is kind of a harder one to remember, but it's 5, 6, 7, 8. So if you ever get stuck and you're trying to remember what times what equals 56, remember 5, 6, 7, 8. So our numbers for this are 7 and 8. So I am going to have x plus 7 times x plus 8. Okay, and now if it's in the numerator and the denominator, I can cancel it out. So I have x plus 7 and x plus 7. So my final answer here is x times x plus 3 over x plus 8. Now, some people choose to multiply that x in the numerator. You don't have to. Some people choose to, but you don't have to. Okay? Let's look at our next one. Our next one is monomial divided by a monomial. We have no addition and we have no subtraction in this. So we are going to break 39 down as far as it can go. Question? I can. We good? Awesome. Okay. So again, this is a monomial divided by a monomial. So in these, you know that it's a monomial divided by a monomial because there are no addition and subtraction signs. So there's no addition or subtraction signs. When that is the case, doing the prime factorization is a good plan. Okay? Now, I really like to do the prime factorization in this one because 39 is not a prime number, but many people think it is, but it's not. 39 breaks down to 3 and 13. 3 and 13. So my numerator is going to be 3 times 13 times x times x times y times y times y. Okay? Now, our denominator, I've got 72. So 72 breaks down to 9 times 8. 9 is 3 times 3. 8 is 4 times 2. And then what's 4? So our prime factorization here is 2 times 2 times 2 times 3 times 3. And if you don't do the prime factorization for this, you might miss that 3 goes into both of those. That's a common one for people to miss. Okay, so I can cancel out a 3 on top and a 3 on bottom. I have 2 x's on top and 2 x's on the bottom. And then I have a y on top and a y on the bottom. So my final answer here is going to be 13y squared. 2 times 2 is 4. Times 2 again is 8. Times 3 is 24. And then I have an x right here. And so that's my final answer for number 2. Is it okay if I go to the next screen? Okay. Number 3, we've got some trinomials, and then this right here is a binomial. So we want to factor. We want to factor. So our first one, I've got k squared plus 13k plus 36. So my product for 36, or my product is 36. And my sum is 13. So this is my product. This is my sum. Okay? This is what we did all last chapter. So my numbers are going to be 4 and 9. 4 times 9 is 36. 4 plus 9 is 13. So I have k plus 9 and k plus 4. Okay? My denominator, my product is 72, and my sum is 17. So I'm going to break those down. The numbers that I come up with are 8 and 9. 8 times 9 is 72. 8 plus 9 is 17. So I have plus 8 and k plus 9. Now, you might see that I've got a k plus 9 that can cancel, but I wouldn't do that yet. I would wait. I would wait on that. Okay, now, for this one, for our second numerator, I have a GCF. I have something I can take out of both of those. So I'm going to pull out that GCF. It's going to be k and k plus 8. K and k plus 8. Now, the trinomial on the bottom is a little trickier. We've had some pretty straightforward trinomials, but this one's a little bit trickier. Our product is negative. When our product is negative, that means one of the numbers has to be negative. One positive and one negative. My sum is negative 5. So our numbers here are negative 9 and positive 4. Negative 9 plus 4 is negative 5. Negative 9 times 4, is negative 36. So we're going to have k minus 9 and k plus 4. Okay? So now we start canceling things out. I've got k plus 9 and k plus 9. I have k plus 8 and k plus 8. And k plus 4 and k plus 4. So I was able to cancel out a lot of things. I have a k and a k minus 9. And I just want to reiterate that k minus 9, you cancel all of it or you cancel none of it. You cancel all of it or you cancel none of it. So those two k's don't cancel because that k minus 9 has to stay together. Is it okay for me to go to the next screen? Okay, now we are going to do division. We're going to do division. What I like to do when I'm doing division is I rewrite it first. Some students will rewrite and factor at the same time. I don't recommend that because you could lose something when you do that if you're not careful. So I am going to keep my first rational exactly the same. So I have z squared plus 15z plus 56 divided by z squared plus 16z plus 63. I'm changing my division sign to multiplication, and I am flipping my last or second rational. So I have z squared plus 14z plus 45. Okay, and then I have that over z squared plus 8z. So my first step is to change to multiplication. Okay, and then my next step is to factor. And all of these are trinomials and binomials, so we're going to be factoring things down to binomials. Okay, so our first one, we have a product of 56 and a sum of 15. And I think we just did that, didn't we? So that is 8 and 7. Okay, so that factors to 8 and 7. Then, my next one, I've got a product of 63 and a sum of 16. So that's 9 and 7. So I have z plus 9 and z plus 7. Okay, and I am multiplying that. Then I have z squared plus 14z plus 45. 45 is my product. 14 is my sum. So that's 9 times 5. So I have z plus 9 and z plus 5. Then I have a GCF for the next one. So I'm just going to take out a z. Okay, now that I have everything factored, I can start crossing things out. Okay, my z plus 7 and z plus 7 are right on top of each other. I have a z plus 8 and a z plus 8. Then I have a z plus 9 and a z plus 9. So I am left with a z in the denominator and a z plus 5 in the numerator. So my final answer to this is z plus 5 over z. Can I move off the screen? Sure. Am I good? Okay. Now, I want you to look at this one. In this one right here, we do not have any addition or subtraction. There's no addition and subtraction. No plus or minus signs. When that happens, that's when you're going to do the prime factorization. You're going to break those numbers down as much as you can with prime factorization. So my 4xy squared, my 4 breaks down to 2 times 2 times x times y. Actually, I don't want to do that first. I'm sorry. Okay. Do you see how this right here is division? We need to deal with that division first. So I am going to keep this the same. I am going to change this, and I am going to flip this. But here, what operation's happening here? What does this dot mean right here? Multiplication. So this stays the same. This one right here stays. Okay? So I am going to keep my first one, So I have 4xy squared over 7x. I change this division sign to multiplication, and I flip that rational. So I have 9x to the third over 7y. Now, this operation right here is multiplication, so I don't do anything except rewrite that. So I have 14x to the third y over 12y. Now that I've got this written as multiplication, I'm going to do the prime factorization. So 4 becomes 2 times 2. Then I have x times y times y. Okay? Then I have 7 times x. I'm going to break 9 and x to the third down. So I have 3 times 3. 3 times 3 is 9. Then I have x times x times x. Then I have 7 times y. Okay, I can break my 14 down to 2 times 7. My x to the third is x times x times x. My 12y is 2 times 2 times 3 times y. Now I can start canceling. Okay, I did have somebody say, can I cancel this 7 and this 7? What do you guys think? Can I cancel this 7 and this 7? No. Why? Yeah, they're both in the denominator. You can only cancel if there's one in the numerator and one in the denominator. So, can I cancel this 7 and this 7? Yes, because one's in the numerator and one's in the denominator. Okay? Then I have a set of 2's right here that I can cancel with these. Okay, I have 1, 3 I can cancel. So it looks like I've got a 3 and a 2 left in the numerator for my numbers, and a 7 left in the denominator. Okay, and those are my numbers. So now I'm going to focus on my letters. I have an X and an X I can cancel. I can cancel this Y and this Y. I have another Y right here, and I can cancel there. And I don't have any letters left in the denominator that I can cancel. So I've got X times X times X times X times X times X. What is that? 6X to the 6th. Good. And then I have a Y. Then what's in the denominator? 7. Okay. Okay. So all of those are simplifying. And your key to all of that, to simplifying multiplication and division, your key to doing that is to factor. That is your key to doing that. Now, our next problems, we're moving into addition and subtraction. Okay? Addition and subtraction. Can I move off this? Okay. So addition and subtraction and solving, the key to that is least common denominators. The key to solving rational equations and addition and subtraction is least common denominators. So that is what we have to find here, is our LCD. We have to find our LCD. And the way we find our LCD is we factor just the denominator. So we're going to factor the denominator. Okay. So having the correct LCD is the key to getting 6, 7, and 8 correct. Okay, so x squared, okay, I write that as x times y, and then I've got x times y times y. Okay, so for my LCD, I've got an X and I've got an X. Okay, and then I have a Y. Okay, when I look at my second fraction, I have an X that I've got accounted for. So I don't need to write that again. I have a Y that's already accounted for. Is this second Y already accounted for? I have to have another Y there. Okay? So, do you see how in this problem right here, my highest exponent for the X was squared? And then here, my highest exponent is squared. So my LCD has to have that. Because I had an X squared in one of them, I have to have it in my LCD. And because I had a Y squared in one of them, I have to have it in my LCD. So if I had a 2 in one, and I had a 2 times 2 in the other, what would my LCD be? And you can tell me the actual number. My LCD is not 2. So think about this right here. Think if those are my fractions. This is 1/2 plus 3/4. Okay? So when I break that 4 down and I get 2 times 2, if I don't have both 2's in the denominator, I don't have 4. I have only 2. That's the same thing that's happening with the variables squared. So you've got to make sure that those are included. Okay, now, so I have 2 times X times X times Y. What's missing? Y. And if I do it on the bottom, I have to do it on the top. Okay? Then, for my next one, I have X times Y times Y. What am I missing? Good. If I do it on the bottom, I got to do it on the top. So, my denominator now is X squared, Y squared. I have 2Y plus 8X. And that is my final answer right there. Is it okay if I move to the next screen? Okay. Okay, again, we are adding, so the key to solving this problem is finding the correct LCD. We've got to find the right LCD. So the first thing that I'm going to do is I'm going to factor the denominator. So I have 5x on top. X squared minus 9 is difference of perfect squares. So I've got x plus 3 and x minus 3. Then over here, I've got x times x minus 3. Okay? So for my LCD, here I have an x plus 3. So that's going to be part of my LCD. And I also have an x minus 3. Okay? So both of those are covered. I've already got those written down. This x minus 3 right here, do I already have it covered? I do. It's written right here, so I'm good. And I've only got one of them, so I don't have to write it down again. So now I can rewrite 5x over x plus 3 times x minus 3. Am I missing anything in the denominator? X plus 3, x minus 3. Do I have my LCD covered for this one? I do, so I don't have to do anything else to that. My next rational, I've only got x minus 3 in the denominator. What am I missing? X plus 3. So if I'm missing it and I have to multiply the denominator by it, I also have to multiply the numerator by it. Okay? So my new LCD is x plus 3, x minus 3. Then I have 5x plus this x has got to be distributed. So I have x squared plus 3x. Do I have anything else I can combine here? Good. What is 5x and 3x? Good. So I have x squared plus 8x, and that's my final answer. Now, number 8 did give a couple people some headaches. Can I go to number 8? Okay. The first thing, well, there's actually 2 things that I would advise. Okay, I would factor my denominators. So I'd factor the denominators, and I would change the subtraction to addition. I would do that. I would do both those things early. Okay? So I'm going to change this minus sign to addition. Where does the negative go? Good. It goes right there. Okay. Now I have 10ab over. Now this a squared minus b squared definitely gave people some headaches. A squared is perfect. A times a gives us a squared. The square root of a squared is a. B squared is perfect. B times b is b squared. The square root of b squared is b. Okay? It's perfect. So, a plus b, a minus b. That's what that factors to. Okay? Then I'm just going to rewrite this because a minus b doesn't factor. So now my LCD, I'm going to write down both of these as part of my LCD. So I have a plus b and a minus b. Here I just have a minus b. I've already got it right here, so do I have to write it down again? I don't. So I'm good. I've got my LCD. Now, my first rational, I've got 10ab over a plus b, a minus b. Okay? That LCD is already covered. A plus b times a minus b already has the LCD in it. So I don't need to do anything else. Okay? Now, for my second one, what am I missing in the denominator? I heard it. A plus b. Good. A plus b. And if I multiply the denominator times a plus b, what do I have to do for the top? A plus b. Good. Okay. So now I'm left with a new denominator, which is a minus b times a plus b. 10ab. I've got to distribute this right here. So I've got negative ab and negative b squared. Okay? Now, 10a and negative ab are like terms. What would that be? Good job. 9ab minus b squared. That's my final answer. Okay, so I just want you to look on your paper. 6, 7, and 8, you had to get those written with the least common denominator. Numbers 6, 7, and 8, because you were adding or subtracting, you had to rewrite those with a least common denominator. Okay? Now we're going to look at 9 and 10. We still use an LCD, but the goal is to eliminate the denominators by multiplying. By the LCD. Okay? Now, what is the difference between number 9 and number 8? What is the difference? Yes, and you said it too, the equal sign. That's what makes the difference. The directions for number 8 is simplify. The directions for number 9 is solve. One has an equal sign, one doesn't. When you have the equal sign, you are eliminating the denominators by multiplying by the LCD. Okay? So, I have to find my LCD. I've got to find my LCD. So I start here, and what do I write down? Good. I start with X, and I write down X. Now, for this LCD, I have a 5, and I have an X, but I've already accounted for that X. So what do I need to write down? Okay. What is my denominator here? Just 1, so do I need to write that down? No, I don't need to write 1 down. Okay, so now what I'm going to do is I am going to multiply everything times 5x. And when I do that, I'm able to eliminate all of my denominators. So I have 1 over x times 5x over 1. That equals 6 over 5x times 5x over 1 plus 1 times 5x over 1. Okay? So this x and this x cancel. What am I left with there? Good. 5x and 5x cancel, so I'm left with 6. Okay, I don't have anything that cancels right here. Okay, I don't have anything that cancels right there, so I write down 5x. And now I solve. I subtract 6 from both sides. Okay, and I divide by 5. Okay, in this situation, and we didn't do this, and I should have. In this situation right here, what values can x not be? What value of x makes the denominator 0? What value? What number, if I plugged it in for x, would make that denominator right there 0? 0. Okay? And then if I put 0 here, 5 times 0 is 0. So x cannot be 0 in this situation. And I should have done that first. And if I had gotten x equals 0 in this situation, what would I have had to do? Throw it out. Good job. Good job. Okay, can we look at the next one? We good? Okay. So again, for this one, we're looking for the LCD. We're looking for the LCD. This is already factored, or it's in its simplest form. This is already factored in its simplest form. This is not. So I've got to factor that. That's what I want to do first. So I have x over x minus 2 plus 1 over x minus 4 equals 2. And this factors to x minus 2, x minus 4. Okay, so that factors. So now I want us to identify what can x not be. What can x not be? So I'm sorry? You're absolutely correct. Positive 2 and positive 4. Okay, and we got that because we took this x minus 2 and we said x minus 2 cannot equal 0, and then we solved. So x cannot be positive 2. Then I do the same thing with this one. X minus 4. Okay, x minus 4 cannot be 0. So x cannot be 4. Okay, do I need to do these two? Do I need to do x minus 2 and x minus 4? No, why? I've already done it. Good. Okay, so now that we've got the values that x can't be, let's find our LCD. Let's find our LCD. Okay, so here I've got x minus 2, so that's part of my LCD. Here I've got x minus 4. That's part of my LCD. Do I already have x minus 2 accounted for? Yes. Do I already have x minus 4 accounted for? Yes. So I'm good. Now I'm going to multiply everything times my LCD. Okay? So I'm going to multiply everything times x minus 2, x minus 4. Okay, we're going to see how small I can write. Yeah, everybody's laughing like it's not going to happen, Alicia. Okay, here we go. So I have x over x minus 2. And I am multiplying that times x minus 2 times x minus 4 over 1. Then I have plus 1 over x minus 4. I multiply that times my LCD, x minus 2, x minus 4 over 1. Okay, then I have equals 2 over x minus 2 times x minus 4, and I am multiplying that times x minus 2, x minus 4. I didn't do too bad. The different colors help, right? Okay. So now I have multiplied every single rational by my LCD. So in my next step, what should happen to all the denominators? They should be gone. Okay? So here I've got x minus 2 and x minus 2. So I'm left with x times x minus 4. Okay? Here I've got x minus 4 and x minus 4. So I'm left with plus 1 times x minus 2. Now, I didn't have to write that 1 down, but I did just to make sure I was clear on that. Then that's going to equal, and these both cancel. So it's going to equal 2. Much easier to deal with. Much, much easier to deal with. So I have x times x is x squared. X times negative 4 is negative 4x. Then I have x minus 2. Now, this is a quadratic. The other things that we've solved have been linear, but this is a quadratic. When I'm solving a quadratic, well, first off, how do I know it's a quadratic? Because it's squared. Okay, this right there tells me it's a quadratic because it's squared. How do I solve a quadratic? What do I set it equal to? 0, and then I factor. Okay? So my first step is going to be to subtract 2 from both sides. Then I'm also going to combine these two right here. I missed that. We need to combine those. So I have x squared minus 3x minus 4 equals 0. Okay, and once I've got it set equal to 0, I factor. My product is -4. My sum is -3. So it factors to x minus 4 and x plus 1. Okay? That's because this was negative. That's my product. My product was negative. So one of my numbers has to be negative. My sum is also negative, so my larger absolute value has to be negative. So I've got x minus 4 and x plus 1. Now I'm going to set each one of those equal to 0. Okay, and so I get x equals 4 and x equals -1. What happened? I got a +4. I can't get a +4. That makes it undefined. So what do I have to do with that x equals 4? Throw it out. So my only answer to this is x minus 1. X minus 1. Okay. Now, here are I hope that your homework is pretty much done. I hope that it's done. That's what I'm assuming. This is what you hit hard for Friday. We had a classwork assignment a week ago. So it was classwork number 1. That's what it's labeled inside Canvas. Classwork number 1. You have the problems, you have the solutions, and you have the video solutions. Okay? Then you have, from Friday, when I did conferences with everybody, you had classwork number 2. That was your second classwork for the chapter. And you had, and I posted the videos on Saturday at about noon. So you had the problems, you had the written solutions, and you have the video solutions. Okay, now you've got the quiz solutions. Okay, you've got the quiz solutions. And you have a practice test A and a practice test B. You have the answers to both of those, and you have the video solutions to practice test A. Now, when you are taking the practice test, put yourself in a testing environment, sit down, take the practice test alone. Then go back and give yourself a grade. Then, if you need to come see me, come see me. If you need to go see your tutor, go see your tutor. If you need to watch the video solutions, watch the video solutions. Then you can decide if you want to do practice test B or not. That's your call. Okay? Okay. Thank you very much.